Okay guys, theoretical aspect of Nernst equation is done. Now let us get into mathematical aspect of Nernst equation. Please try and understand it very well because I've tried to make you understand each and every step with full depth. Alright, hope it helps you. Alright. Okay guys, let's try and solve this sum. Calculate the voltage of cell where this is given. Now E0 Sn is equal to this is also given, E0 Ag is also given. Now mind you, these are all reduction potentials given. Alright, and this is the Nernst equation that we saw right now. Alright, okay, now let's find out redox first. Now in this case, this is anode, this is cathode, salt bridge. Alright, I would just write ionic reaction. Now so Sn plus Ag plus gives Sn2 plus Ag solid. Here Sn is solid, here Ag is solid. Alright. Another interesting thing is, now see, if you see Sn to Sn2 plus, there is, obviously it's oxidation, so as it's anode, but there is loss of 2 electrons. Alright. Whereas here you find that Ag plus has gained 1 electron. Alright. So what do? So obviously in order to equilibrate electrons, we have got to multiply this by 2. We have got to make it to 2 electrons. So if we make it to 2 electrons, we have got to multiply here also with 2. Alright. So yes, this was oxidation and that was anode, and this is reduction and that is cathode. Alright, so no problem. Now let us also write the cell reaction. This is the cell, this is what ionic format. Now let's also write cell reaction to understand it clearly. So this is what is overall reaction. Alright, now what has happened over here? Now see, this was 2 electrons, so this and this gets cancelled, so we don't find it there. So what we are left with is Sn is solid Sn, alright, and silver with its concentration. Now why 2? Because we have multiplied this with 2, this entire thing we have multiplied with 2 to cancel electrons, and then when we go to right hand side, we are left with Sn2 plus with its concentration and silver solid. So that's what is overall reaction. Alright, now let's progress ahead. First job in our mission is to get E0 cell. So E0 cell, already mentioned, is it is E0 anode plus E0 cell is E0 anode plus E0 cathode. Now, so already learned that in ECS all the value given is for reduction potential. So in order to convert it into oxidation potential, we have got to multiply it with minus. So let's do it. So to do minus into So this minus minus would turn plus. So this plus this comes to this volt, these many. So the value comes to these very many volts. All right. So now our mission is what? Now our mission is we already have got this. So let's get into the actual EMF of cell in non-standard condition. It would be, let me just substitute this directly now. Now here when I am putting in here, we have got product. In product we have got silver. So as already mentioned, this would be unity. For solid it's unity, so it's 1. So I'm not mentioning it over here, but SN2 is there. So I'm going to write concentration of SN2. I'm directly putting it. I'm directly putting in the concentration of SN2. All right. So it is 0.02 moles. And similarly, in case of reactant, concentration of reactant, I'm directly putting this concentration. All right, because we have got to put in silver, whereas this would be 1. So no need of this. All right. So the concentration would be 0.01 mole. Now another thing that I need to tell you is I wrote the concentration, but we find 2 over here. All right. So as equation mentioned earlier, this becomes the power. This is the mole. So this becomes the power of 0.01 mole square. All right. So our formula now, so it gets to all right, this is square. All right, 0.01 square. That means it is 0. Moles, which would be, if I just cancel, this would be 200, right? So this would be, we can do cancellations, right? In case of log, we can do cancellations over here. All right, so 1, 2, 3, 4, and 2. So this was what? This was 2 into 10 raised to minus 2, and this was 1 into 10 raised to minus 4. So when it goes up, it becomes 2 into 10 raised to 2. So that is what is equal to 200. Now here I told you that this we can do cancellations. Like for example, if you just want to check that out, what I mentioned over here was that your numerator was 2 into 10 raised to minus 2, this one, and this is 1 into 10 raised to minus 4. So when this goes up, it becomes 2 into 10 raised to minus 2 plus 4, which is equal to 2 into 10 raised to 2, which is equal to 200. This one thing I showed, that you can do cancellations within the bracket. All right. Now for example, if it would have been suppose log to the base 10 of 4 upon 2, you can do cancellations like that inside. All right, and so it would be log to the base 10 of 2. All right, so that's one thing that you have got to keep in mind. Another important thing that you have got to keep in mind is here you just have got to see only till log. You don't have to go for anti-log. All right, so let me show. So characteristic, how I teach log, I'll tell you. Now see, point is over here. So I've shifted point from here to, I've got to shift the point to units place. So how many places have I shifted this side? I have shifted 2 places. So my characteristic would be 2 point. All right, and now I've got to see 20 in 0. When I see in logbook 20 in 0, it would be, let me get it. So in logbook, I've just got to see 20 in 0. All right. So 20 in 0 is 3010. So I would be putting this value 3010. So this is what it is. All right. Maybe I'll also take a small session for log, a simple way to calculate log. I'll put that later on. All right. So this is what it is. So what two things that I told was, you can do calculations inside like this in the bracket within the log. All right. Second thing is, you just don't have to find anti-log. You just have got to go to log and leave it as it is. So what we did is we found a characteristic to be 2, and then this we found out from logbook. 20 in 0 was this value, so we got this. Alright, so this part on calculation comes to 0.936 volt minus 0.0681 volts, and that comes out to be 0.8679 volt. That comes out to be 0.8679 volts. So this is what is our answer. Alright, just to recap, calculation was there, Nernst equation there, product over reactant, concentration of product over reactant, log 10, then N number of moles. We had confusion there. Why? Because when we are doing oxidation, it is losing 2 electrons, but when we are doing reduction, it is just gaining 1 electron. So we multiplied this by 2. So now it became equivalent. Alright, 2 electrons lost, 2 electrons gained, but by 2 silver ions. Alright, done. Then we do overall reaction. So we put in half cell reaction for anode, that is oxidation, half cell reaction for cathode, that is reduction. And then we do cancellation. What we saw, basically our main aim was to cancel electrons. So we multiplied this by 2, we got it, the entire thing was multiplied by 2, so 2 electrons got cancelled in bargain. Ultimately we end up with this overall reaction. Now once we are done with this, our number of moles of electron fixed, 2, n is equal to 2, we got it. Then we calculated E0 cell. E0 cell, we know what has been provided is from ECS, and in ECS we have reduction potential. So we have got to multiply for anode, it is oxidation, so we have got to multiply with minus for the reduction potential given for Sn. We did that. So what we end up with is E0 cell. Once we found E0 of cell, we substituted in our Nernst equation. This was number of moles of electron, 2. Alright, and here then I told you that this inside you can do cancellation. Now for example, if it would have been 4 by 2, you could have cancelled, and then you would get log 2. You have got to check out for log 2. Alright, so you don't have to do log of 4 minus the log of 2. No, just cancel it there and then you get it. Alright, so that's what I did over here. I did it in terms of 10 raised to minus 2 and minus 4. I hope you understood this part. Then here I showed you how we go in for log, and I also showed you how do we find characteristic. Now since this was 2 digit here, my main contention is to bring decimal to unit place. How many digits did I shift? It was 2 digits I shifted towards left, so it is 2 point. But if suppose if it would have been 0.0036, our contention was to shift decimal from here to here, but in right direction, right? So in this direction. So when we do how many digits? 1, 2, 3, 3, but the characteristic would be bar. It would be bar 3 point, and then I've got to check out for 36 and 0. That would be our log. I'm going to take it up in one video for finding out log. Okay, doing that, final answer was 0.8679 volts. I hope you understood, and we'll be coming in with more of such numericals. Alright, I hope this video was helpful in understanding numericals in terms of Nernst equation. Alright, keep solving more of these numericals. You will find it very interesting. Alright, and would help you. Alright, so study well. All the best.